Hello guys, and welcome back. So in this video, we are talking about inheritance. And for this course, I can say that it's one of the, or actually the core concept or the core topic that makes up probably about 60% of your module. So you cannot say you've done this module if you don't fully understand inheritance. So we are going to spend quite a bit of time talking about inheritance. And understanding all the concepts around inheritance. So just a brief introduction in terms of how things are normally structured when we discuss inheritance. The first thing you're presented with in most cases is a UMO class diagram. A UMO class diagram is used to give you an indication of how your classes are related to each other and also the structure of your classes. So you have to understand and be able to interpret a UMO class diagram. And we're going to do a few examples together just to understand how do you interpret a UMO class diagram. And the next thing that you have to understand also from a UMO class diagram is the relationships between those classes. And we are going to break down three types of relationships. The first one being composition, then aggregation, and then association. We'll do this right at the end, probably. We'll see how we structure things. But when you look at a UMO class diagram, you have to be able to realize which relationship is composition, aggregation, or association. Understand what makes it that, what makes it composition, what makes it aggregation, or what makes it association. Now, this can go further beyond these three types here. But for the purposes of our studies, we are only going to stick to these three, right? So that is also another thing we're going to look at. Otherwise, whenever we talk about interpreting a UMO class diagram, you must be able to define all your classes from your UMO class diagram. So given a UMO class diagram, can you then go in your IDE and define those classes? And this works both ways. Also, given classes, are you able to draw a UMO class diagram? So it's a very one-on-one or one-to-one translation between the diagram to the class definition or from the class definitions back to the UMO class diagram. So this is what you need to be able to do. And I'm saying these things so that you can self-check and see if you fully understand how to deal with UMO class diagrams. And the next thing is class implementation. So class implementation isn't really something to do with a UMO diagram. This is a spec that you are given in terms of what each function in your classes does, and then being able to implement all of those functions. So in other words, whenever we talk about implementing a class, basically all we are talking about is being able to implement all the functions that are in your classes. So class implementation is equal to function implementation. So you implement all the functions, excuse me, according to the spec or the description or the functionality that is detailed in the question, as you see in a few examples. Now, when it comes to inheritance, there are a few things we're going to emphasize on that are very important and crucial to understand, mostly abstract classes. And what are they? What are abstract classes? What makes a class abstract? And how do abstract classes differ from concrete classes? In other words, when I mention abstract classes, that is introducing a type of a class, right? Which means if we've got abstract classes, then what is the other type? We've got abstract, and then we've got concrete classes. Concrete classes are what I would say you already know how to use, a normal class that you can define and then use. But abstract classes have something special on them that we are also going to discuss. And one of the most important aspects of abstract classes is how do you identify an abstract class given a UMO class diagram. So our first example is not going to include abstract classes. It's going to be a very simple example, no abstract classes, just normal classes or just concrete classes. We understand how to interpret that diagram, and then we move on to implementation. And then lastly, we then talk about how to use your classes. Now, when it comes to using your classes, and this is how we summarize inheritance, you have to understand the concept of polymorphism. You cannot say that you have fully understood inheritance if you don't understand polymorphism, right? just pardon the typo that is here, understanding, it's understating. So sorry about that, understanding there, right? So you cannot say that you have fully understood polymorphism, I mean inheritance, if you cannot explain polymorphism. So no matter what I want to do is we start off with a UMO class diagram, we move on to defining the classes, we go on to implementing those classes, we go on to use those classes, and until we get to that point, or after using our classes, then we can go back where we started, defining our classes and understand the concept of polymorphism and how it's realized in our Qt framework. All right. So I'll try and include as many examples as I can, but this is just a brief overview of how things are going to go as much as inheritance is concerned. Thank you for being here. I'll see you in the next video.